Okay, yeah, so I'll be talking about RPCs. Maybe a quick summary before the talk, what I'm going to tell you guys. I have worked with one of the RPC frameworks, so I'm going to tell you why did we decide to use it, which problems did it help us to solve. And also I will dig a bit into the protocol details and compare the solutions that we used with other options, because it appeared that there are actually a lot of different RPC frameworks, and I decided that it's interesting just to know what are there on the market. And before I start, I need to add that suddenly jet lag hit me only like recently, and I feel sleepy and nervous at the same time, and I hope I won't fall asleep right now, so be ready to save me. Also, I noticed a pattern that all the foreign speakers, they start with some pictures of their cities and pictures or maybe maps, and I'm not an exception here. So first I'm going to tell a few things about Belarus, because I assume that not a lot of people know much about this country here. So yeah, Belarus. It's here, it's in Eastern Europe. In some French newspapers said that this is one of the top countries to visit in 2020. So probably this is going to be even the most useful information for you than the RPCs actually. So Belarus makes the biggest trucks in the world with the highest capacity. The name is Belaz. Also, it's the third exporter of potash salt. I hope I pronounce it right. The first place is Russia, second is Canada, and we are the third one. This is the national animal of Belarus, European bison. The animal was almost extinct by the end of the Second World War. But right now, the population of wild animals is about 2,000 of them, so they're pretty safe right now. Another not so well-known fact about Belarus that we have a very strong school of modernistic art there in the Vitebsk city. A lot of famous artists in this style created their works there. Also, Belarus is the proud holder of the ugliest monument in the world. According to CNN, the name is Courage. It's located in the Brest city. And the last one, an important fact, that Belarusians consider it to be the people who consume the highest amount of potatoes in the world. It's about half of a kilogram for a person per day there. Yeah, so now let's get straight to the point. What is RPC? RPC is a remote procedure call. It is a protocol that one program can use to call a service from another program located somewhere in the network. The term is not new. It's actually pretty old thing, and programmers were using it for maybe for a long. It's become to be popular among web developers only recently due to the rise of microservices and service-oriented architecture, because RPC helped to solve communication problem between distributed services. And RPC framework obviously is something that helps you to build RPC-based solution. What you need to know about RPC frameworks, that usually it's not a monolithic framework, but rather a collection of technologies. So you can choose the way how you want to encode data, the way how you want to transfer it, and there are usually different options to pick within the same framework. In 2020, there is a lot of them, such as gRPC, TWIRP, Swift, Kaplan Proto, Vineangle, Dubo, Avro, and that's not all of them. It's just the list that I included in this presentation. And what kind of interesting of this solution, these frameworks, sorry, that almost every one of them is backed up by a big corporation. For gRPC, this is Google. For TWIRP, this is Twitch. For Swift, this is Facebook. For Kaplan Proto, okay, this is a bit outstanding here. Vineangle is for Twitter. Dubo is from Chinese Alibaba. I hope I pronounced it correctly. And so on. So usually RPC's frameworks is something that big corporations need, and it's kind of hard to build it, you know, for open source enthusiasts. So usually big evil something stands behind. I'll start with gRPC. This is, well, spoiler alert, the one that I have the most experience with. gRPC is one created by Google, and it is implying protocol buffer-based services, automatic generation of client and server code, and the killer feature is bidirectional streaming for this one. Also, it uses HTTP2. And now I'm going to tell you why we use this. What was our system. So I was working on a company with quite a big system consistent from more than 50 different services. And I'll show you a simplified schema. How did it look like? We had an AWS Lambda function, which was triggered each time something was something happening at our S3 service. Like some file was uploaded, deleted, or something. Basically, anything was going on there. And the Lambda function was sending a special message for our managing service. And this managing service was sending HTTP requests to a lot of other services. In the real life, there was more than 50, but, well, okay, it's a simplified version. And at the same time, we had not streaming, so the managing service was subscribed to different queues. Like when, for example, packages or titles or other services were finishing their job, they sent messages to the queue, so managing will be aware that the processing is done. So this is basically what we had before, and it was working for us. And at some point, we decided that we want to change it. And the question is why? First of all, we had issues with not streaming. I mean, at this point, maybe some of these issues are already fixed in their GitHub repo, but at least what we've seen that sometimes not streaming cluster had really big timeouts with not so many messages, because, well, the load actually on our service wasn't so big. It is an internal system, and maybe like 10 messages in a minute or something, so the load is relatively small, and even with this kind of sequences, it was already dead. And another problem that some subscriptions suddenly just stopped to receive messages, and also we were fighting it for quite some time. And then there was this decision that we need to change the way how are we making things. As migration options, we considered Kafka, Rabbit, SQS, SNS, and Kinesis and RPCs. The final choice for us was ActiveMQ backend with gRPC as a communication mechanism. And what stays behind this decision is politics, because we had rather big DevOps department, and these guys, they were really interested in trying new things, like writing something in Golang, maybe something connected to gRPC. So they insist, and well, actually it turned out pretty well for us, because we received what we wanted. And this is the final scheme. So now we also have the managing service, which is still licensed to AWS. But in the middle, there is an RPC server. And also, it's not on the scheme, but each of the services has RPC client. So each RPC client is subscribed to the RPC server, and all the data is picked up in the ActiveMQ. And this is actually works quite reliable for us. We are getting the stuff done with this system. Well, I think I missed some slide. Okay. Anyway, there was one more slide. We saw that maybe the best choice, at least for our problem, was Kafka service. But Kafka is considered to be hard to maintain, hard to configure. So we, also DevOps guys, so we decided that gRPC is the way for us. But well, I'm rather concerned that my slides are gone, but okay. Okay, what are the advantages of Protobuf? Protobuf is the way how do we send messages. This is kind of mechanism that I will add more details on how it works later. But it helps to keep the messages small, so we saved a lot of money on the traffic. Another great advantage of gRPC is shareable schema definitions, because all the clients, they share the same schema, and you can just change the message format somewhere and break it everywhere else. So it's quite safe, especially in our system, because we have quite isolated teams. Even I worked in a Ruby team, and we didn't have permission to see repositories of other services, and we didn't communicate much with other teams. So so there is no way that someone can, for example, in Java service, change something and break everything in our team, because we all have the same schema. Next one, login. Login also great in our service, because well, basically we did it all manually in the server, and in the client part we can log whatever we want, and it become much more easier to debug the system. Because, for example, compared to not streaming, when we had issues with heartbeats or these messages, it was really hard to dig into the logs, and we spent a lot of time just trying to figure out what was the issue. Yeah, after thought. So this was the slide that I was looking for. Yeah, we thought that Kafka maybe was a better choice for us, but gRPC works, and it's great. So implementations. Currently there are blessed 4 of implementations, like Java, Golang, Python, and C++. Blessed 4 means that all the updates, all the security fixes, and this stuff comes first to these languages, and the rest needs to wait. For example, for Ruby, when we migrated, I don't exactly remember the versions, but maybe from 2.4 to 2.5, we couldn't migrate because there was a conflict with gRPC gem, and some C library was throwing exceptions, and we were forced to wait till Google release an update. But it wasn't for too long, maybe 1 week or so, and we were able to be up to date. As a transport, gRPC provides next options. You remember I said that it's not monolithic, so you can pick whatever you want, like HTTP2 or cronnet or in process. In process is local when you don't want to set up the protobuf itself and all this difficult infrastructure, and you just want to test your messages in the same process. The list of gRPC protocols are here: protobuffers, flat buffers, and all the others. We will look in more details into protobuffers because I think it's just, well, usually as a developer, you do not need to know exactly how it works because this is a black box for you. But I think it's rather interesting just from high-level perspective to understand what is protobuffer, what does it mean, and why it helps to reduce the size of the messages. Like how in the world anything can be more effective than JSON, for example. Just all these kind of little details. So protobuf, this is a method of serializing structured data. It guarantees type safety and backward compatibility due to the shareable schema definitions. Well, it guarantees fast serialization and deserialization, and is smaller than other popular formats. So here is the schema definition, how it looks like in real life. Here you can see several messages. So it includes the data type, like for example string, then the field name, and the field number. Field number must be unique within the same message, because in the serialization itself, it won't use the names, it won't use these unique numbers. And you can change the name if you'd like to, but the numbers, they should be the same. And at the end of the file, you can see the service which describes which messages your gRPC system is able to send and receive, and which data types it gets from it. And and this proto file should be shared between all services, between all clients, and in the server, it all should be the same. Here is a dump of HTTP request with hello world message written in JSON. Here you can see that the file data takes 25 bytes, so it's just a plain HTTP and JSON content. And let's compare it with the same message, but sent via gRPC. So here you can see that there are much more different helper messages that are being sent on the network, like some kind of pings, settings, and this kind of stuff. Also pay attention on the length. But the message data itself is 13 bytes. So it's 2 times smaller than the same message in JSON. And when we will be considering higher, like the biggest messages, the data saving would be much better, because the message is small. The bigger it gets, well, it will get a better compression. But at the same time, pay attention that the gRPC takes much more messages with bigger lengths in total. So in case if your system sends very rare small requests to each other between services, so maybe in your case it won't help much. But when it comes for our system, we had rather frequent and big messages with like giant contents inside. So gRPC for us saved a lot of data, and also it wasn't too heavy on the network compared to HTTP. Now, 1 second. Now let's dig into the details, how exactly protobuffers help to compress the messages. So let's imagine that we have message hello request with single attribute content of data type string. And let's imagine we need to send hey message over the network. It will be converted to this byte sequence. What does it mean? The binary form follows. First of all, gRPC has different type numbers for different data types. And in our case, it was a string, and it means it is a length delimiter, so it's type number 2. And the first byte in the stream always contains this data type. So whenever this is a gRPC message, you can be sure that the first byte will tell you what is the wire type and also a field ID. So what it needs to do, it drops the most significant bit to determine whether it is 0 or this is 1. And in case if it is 1, it understands that it needs to read the next one till it finds the first 0. But in our case, it was 0, so the system can realize that all the information are within this first byte. And the last 3 bits of the number store our data type. So it's 0, 1, 0, or 2 in binary, the string data type. And the rest is the field number. So 1 is the rest. The second byte for like we already detected that our data type is length delimited or string. So the next byte for this data type contains the amount of bytes to read. So it is 3 bytes encoded in UTF-8. Hey. So yeah, this is how protobuffers work. And usually you don't, not usually always, you don't need to know it because gRPC will generate automatically services for you to encode and decode messages based on your protofiles. It uses a special proto-compiler to be able to do it. For Ruby, it is a special gem named gRPC tools. You don't need it in production mode because it used only to generate classes based on your protofiles. So to summarize the gRPC thing, it has a great documentation. Also, this is a Google product and they are trying to keep everything documented. It has big community, so in case if you have any questions, you will be able to just Google it, and probably the first answer on Stack Overflow will lead you to the right answer. Also, it uses HTTP2, and the killer feature, full duplex communication. And when it comes to cons, this is this thing. It actually becomes better and better because I made this presentation a couple of months ago, and it was 800 of issues, and right now there are 700 of issues. So, well, maybe in a couple of months there will be 0 of issues. But right now, a lot of questions, and a lot of them are about load balancing, because it works on HTTP2, and Google kind of suggests to use some special kind of load balancers. But well, if you want to dig into details, you can look through the issues yourself. Well, next one that we are going to look at is TWIRP. TWIRP designed by Twitch, and it is inspired by gRPC. So basically, it is a total clone of gRPC. Implementations are, well, here. You can see quite a lot of them. So for transport, it suggests to use both HTTP or HTTP2, and for protocol, it's protobuf, binary, and JSON encoding. So when TWIRP creators or Twitch were telling the idea behind it, the main goal of this framework is to be able to work with regular load balancers. So they made gRPC support HTTP 1.1. And this is the idea, but due to this, they need to support both the first one and the HTTP 2, and due to this, they abandon the full duplex communication because it works only for HTTP 2. But well, at least when it comes for the system that I was working on, it was fully internal communication, like the hidden internal system, and it's not open to the outer world. And we were solving our load balancing issues in our own way, like via some weird service discoveries and some HashiCorp products. But for example, for TWIRP, from what I understand, they are making gRPC connection between client on the side of users and the server, like hidden between load balancers. So in this case, probably TWIRP can help. Next one, Apache Swift. This is the oldest one, and this is a framework created by Facebook. There is a legend about this framework because it says that some time ago, Google created like stubby protocol, and it was created way before the gRPC, but it was internal. They didn't made it open source and used it for their internal thing. And at some point, they hired an intern who didn't finish an internship. And then this guy or girl or someone, they joined Facebook and kind of stealed the idea. So Facebook built their Swift on top of this stubby thing. And this is why you will see this, that the idea is very, very similar. But Facebook did a politically right decision to make it open source right when they created it, somewhere in the 2007 or something, maybe 2012, I forgot the year. And due to this, the TWIRP, Swift is used widely in a lot of systems. It has a lot of implementations. But what is surprisingly weird that it has rather bad documentation. It's kind of hard to find solutions if you have some specific problems in the docs. For the transport, Facebook created a lot of their own stuff. So I'm even not sure myself what does it mean, but T-sockets, T-frames, and this kind of transports are available. And the same goes for Swift protocols. Swift, for example, is very similar to .proto, for example. The same structure, but it uses a bit different names and a bit different notation, but you can see that basically the idea is the same. So the schema just describes the messages and the service, which messages it is able to receive and to send. Swift comes also with a compiler. For the pros, I can name wide languages support, because, for example, if you have a very unique language, then probably, and you want to use RPC between multiple services with these weird ones, and probably Swift will be the framework which can cover this for you. And also, I wrote it as a pro, but I'm not sure myself. Currently, Facebook works on the new version of Swift, and they kind of hiding the details, so no one really knows what it is going to be. But all are excited and are waiting. For cons, it is a poor documentation and also no full duplex streams. Captain Proto. Well, this is this last one similar to the whole ideas, because, well, the story is the same. The guy named Kenton Varda worked at Google, and he was a tech lead for protocol buffers, and then he quit Google and created his own Cup and Proto. This is a screenshot from their site. So they claim that Cup and Proto infinity times faster than a protobuf because they are not using encoding. But it's not, well, this is kind of marketing move because they are using serialization, and encoding is kind of subdomain of serialization. So what they're doing, their data is arranged with fixed widths and fixed offsets, and can be packed by specific scheme. For implementation, here it goes. Also quite a wide list of possible options. Ruby is here. Yeah, but when it comes to Ruby, it seems like it is kind of abundant, because yeah, the last update was a long time ago. Yeah, here, well, so all those frameworks that we already talked about, they are different but similar, because, well, they share the very similar idea of this schema definition. They have clients and servers, and well, this is a special way to encode messages, to decode them, and the next RPC frameworks that we are going to take a look at are kind of different. We'll see. The next one is Finagle. This is one built by Twitter, and it is used for JVMs. It supports also Thrift, MySQL, which is interesting because you can send messages directly to your MySQL. And it supports both HTTP 1 and HTTP 2. The main idea behind Finagle is a thing named futures. This is something described in Scala, or maybe familiar to Scala people. But when we come to like Ruby world, maybe this is something similar to Ruby fibers or maybe JS promises. Well, it's also different, but well, if you're a Scala guy, you'll understand. When it comes to supported languages, well, all JVM compatible, and in theory it should be JRuby as well. But in practice, I didn't manage to find any example or any working project with Finagle and JRuby. Basically, all my Googling ran into a single question somewhere on Stack Overflow, which was asking, are there something for JRuby and Finagle? And there were no answers. Oh, we are kind of moving. Oh no, it's 40 minutes. This is the first time I'm not making it in time, so I hope to speed up. Yep, I said I'm kind of sleepy, so sorry. I'll try to be faster. So yeah, Dubo, the next one. This is one created by Alibaba, the Chinese giant. And this is still in developing mode, so it's not completely finished. And they have a really complex idea behind it. They have some kind of monitors, consumers, providers, containers. Daba comes together with some kind of UI interface where you can follow all the messages and keep track of the data that you send and receive. Protocols are here. Also some kind of a lot of weird stuff. For implementation, it's Java, Python, Node.js, and PHP. No Ruby, but well, for some reason I decided to include it. Well, okay, we're almost there. Avro is a remote procedure call and data serialization framework for Hadoop projects. This is also a bit outstanding from the others because it uses dynamic typing. And all the schemas are defined in JSON. So basically the idea is that first whenever you establish a connection, first you send your schema written in JSON, the server receives it, and then you send all your data. And each time it can be a different schema, just so the receiver can understand and decode whatever you send. It works well for some big data when you're uncertain on which data exactly you would like to send. And it supports Ruby as well as a list of other languages. So benchmarks. This is rather hard question because once again, the frameworks are not monolithic and it's not clear what exactly should we measure, like which should we measure like protobuf or compare them to flat buffers or to some raw data or to JSON encoding, also different transports, and you even can't compare all the combinations within the same framework. So it's kind of whatever suits best for your data. The results can be different. And the last thing I need to mention is DRB. This is a thing that helps processes to talk to each other, and basically this is RPC in pure Ruby. This is kind of abundant right now. Well, not as abundant, but it's not widely used. But as far as I know, in Rails 6, they have used distributed Ruby to make possible parallel testing. So this is still alive. Also, I know that it's being used in Red Hat company. But I met at one of the conferences, I met a guy from Red Hat, and he was like, well, we don't recommend to use distributed Ruby, so don't mention us, but it's too late. Okay, so yeah, I think this is it. And here are the sources that I used to create this talk. Thank you.